share the screen. Yeah. All right, we're live. And put this up. Let's see, is it upside down or right side up? What do you think? Upside down or right side up? There we are. Gotcha. All right. When you do watch these videos, bear in mind as you're watching it you'll be watching them as YouTube videos. You can make the screen the size of the screen.
Right, yeah.
There are things you can do. Yeah, especially if you're watching it from your recliner or something, big display would be nice. What was I gonna do? Okay, so I'm recording now and let's go and see what we're doing today. That would be in the syllabus. So we're doing 3.4. You guys have any questions? Let's start with that first. No questions? Okay. This may generate questions from you. Let's go back into, was one of these Blackboard content? There it is. Hop into Alex. New window. So we did some applications last time. That word means word problems. Applications. What do you think this means?
Yeah, that's what we,
More word problems. There was, are you guys familiar with the Far Side cartoon?
no.
He writes just funny little things. And one time it was showing the library in hell. And it shows the books that make up the library. And Satan, of course, is laughing because he created this library. And it's all word problems. All right, we should talk about percentages and what they mean. So let me do that first. I'm going to start a new page. Oh, let me delete these and at least some of them. Delete that. Yeah, it should be enough. So we know in this section here. Okay. Did I not copy that?
I thought you did.
I thought I did too. It's an end up where just write the thing. All right, watch, I'm gonna do it. Copy. Paste. Okay,
This doesn't want to.
Control V. No, it does not. Well, I noticed in some places, like some email applications, they will disable that. So that you can't get malicious things. So what we're gonna do then is I'm gonna do it another way. So go take this one. I didn't take, it's always taken this one, so we'll see how it goes. All right. Applications involving percents. Let's talk about what a percent is, and then we'll start doing the problems and seeing how a lot of times you'll want to go in and out of a percent, change from percent to a different type style of number and back and forth. So let me start with the basic definition of a percent. What is the definition of 1%? There's two, actually. So there's 1%. One version of it is that it's 0.01. That's the decimal version of it. But as a fraction, it's 1/100. So what I'm getting at is do you know what cent means? Cent is 1/100th. So, okay. a cent, a penny,
Yeah.
1/100th of a dollar. So what we have here is that last part, you could look, this might be convenient to look at it this way. So let me give an example real quick. 40%. What do you think that equals if I change it to a decimal? 0.4. 0.4. Because the thing is, this introduced two decimal places, didn't it? So you're gonna introduce two decimal places into the problem itself. Go to the left. Most students will actually leave the second zero on there, although it's not required at all. But I guess they're feeling more confident with it in that format. Now, if you know your number values, your place values, it's the easiest thing in the world to convert from a decimal to a fraction. I have 0.40, right? What is the location of the 4 in there? That's tenths. What's that 0 in there? Hundredths. So you know that this is 40/100ths. You just said the fraction. And we will simplify it only if necessary. But this tells you all three things right at once. So this will be needing is to jump inside and outside of parentheses. We'll need that as we go along. So let's see what kind of problems they have in this chapter or this section and start rolling. Does this read to you? Is that what that does? Yeah, I guess it does, doesn't it? And yeah, everything nowadays. Now, for these kinds of problems, they are the most straightforward that has ever existed, and I'll show you what I'm talking about. Let's pop back into here. Back. Okay. Here's the rules. This is the rules of our meeting. Do you understand my notation there? Is means equals.
Means many times.
Right. Oh, means time. Let me put those in quotes since we know what we're talking about. Is and of. You'll need to be able to work with those two words, is and of. That's it. Oh, let me turn up the volume, I think. That's loud. Still go high. So what we do is this. I actually write an equation directly underneath of the set of the question. So you see what I'm talking about. In mathematics, we allow ourselves the letter to represent an unknown quantity. Right? X typically. So when I use the word what, I'm asking you for some number X. You with me? Is. Now, you do not want to work with a percentage in percentage format. You'll always be dropping out of it, most likely into decimal, but possibly sometimes into fractions. So here, tell me what it is as a decimal. 0.31, 0.31. So I'll put 0.31 underneath of that. The of is the multiplication dot 65. Now it's just a calculator exercise. Let me grab one.
You want dates, sir?
What's that?
You want dates, sir?
What'd you get?
20.15.
20.15? Is that all the decimal places?
Yep.
21.15.
20.15.
Everybody good? Did you get your 20.5 on that? 20.15? Good. So this is the game. I'm gonna give it to you. All you need to do, you're gonna get some sort of an equation is all. This was remarkably easy because X was already isolated by itself. That won't always happen. So it says what? I gave you the value. There's our answer. The things will get mixed around. The what will appear somewhere, the is will appear somewhere, and the other, they may mix them around. But as long as you know what they mean, you can write these equations really easily. Let's do another one. Of the word problems you're going to encounter in this section, these are the easiest ones. Let's grab another one here. So what I want you to do is I want you to write it out. It doesn't take that. Weird. All right, I want you to write it out first, the equation. And I'm sorry, write out the question and directly underneath of that, write the relevant equation. Okay?
So I put 30 equals 12% times X.
Okay. Change that 12% to a decimal. That's what you actually want to work with.
0.12.
That's right. That's right. Exactly right. The equation that you should get goes like this. 30 equals 0.12 times X. A simple equation to solve now. What do you do to find the value of X now?
Multiplied by 0.12.
Divide both sides by 0.12 to get X by itself. I got 250.
Yep.
You 252 as well. All right, so all these problems, all they're gonna do is move stuff around on you. So as long as you can set up the equation, all the equations will never be harder than this. This is as hard as they get on these types of problems. In fact, I don't even know a way of asking you that's not in this format. Let's go here.
So that's, so that means that's 8.4 on.
That's not what this is. You didn't move that point, did you? You gotta move that decimal. You're gonna change it from that percent.
Percent, I'm moving to the right.
No, to the left. If it's in percent now,
Is that right?
yeah, that's not gonna be 840, no. That's 8.4 out of 100. So it's not even 1/10 yet. The decimal goes which way now?
The decimal goes to the left.
That's right. Did you get 180? All right. Where's my thing? We have this moved to the left 2 places, so it's 0.084. I'm going to talk about this for just a minute. Of what number means that I have times X on the left hand side. Applications, hence the memory application, so you'll see a lot of glitches happening. All right, then to solve, what would you do to solve this? You want to get X by itself, how would you do it?
Multiply.
Not multiplying anything. Remember, solving an equation is an undoing process. If you want to get that thing alone, what you need to get out rid of. Get it out of there, and X will be by itself. How do you do that?
So we divide.
Right. Divide by 0.084. This came out really good, came out 180 for X. So I'm just gonna go through each possible iteration of these problems and throw them up for you. So you'll have seen every type that you can possibly have. Where's the mouse? There it is. This one's a slightly different brand of question.
Yeah, I guess something like that, when I'm dividing.
Go on. Did you get your final answer?
I have to.
But did you work? Yeah, that's it. That's right. That's right.
Okay. So I divide I'm dividing this into this number. But when you divide, you gotta bring the decimal thing.
You got there. Follow that. Notice what it's asking you for this time. It's not asking you for a regular old number. What is it asking you for? So you got to convert your final answer to a percent.
Yeah, 90 equals times 225.
What's that? Yeah.
I said, this is how like.
I get X by itself. So what do you do? Which one do you get? Right. You can divide by that. Right. You weren't here. So you'll watch when I do, they're all similar to what I'm going to do here. Okay.
Even this chapters. I don't know.
We don't have one of these?
I'm going to cover it.
Okay.
Yeah, I ordered it.
So the setup, I'll tell you what you didn't get to see. we're using two key words in this problem, is and of. Underneath, you can literally create a set of equation directly underneath of these problems. What percent? I'll call it X. Of is multiplication. So the equations, the resulting equations of these problems are very simple. Now, if I want to get an X by itself, what do I divide by?
225.
Divide by 225. Let your calculator do all the work. My calculator gave me 0.4. Is that correct? Technically, it's not what they asked for, was it? What did they ask for?
A percentage.
Right, so how do you make it a percent? What are you gonna do is,
Minus 4 with the percentage sign.
so the other two places,
That's 40,
40%.
40%.
Okay, so that's nature. You were writing the second equation directly underneath with the words. And you're able to get a very simple equation to solve. As I said, these are the easiest types of problems, and most people get these pretty easily. They do well on them on the tests and all sorts of stuff. So it's not a difficult concept. Where am I going now? All right, one more of these, and then we'll go to the different style of problems.
So it's X times. Equals.
Other? Just don't say anything else, just finish the whole thing again, and then we'll look at your answer. I appreciate your enthusiasm. What'd you say?
25.
Now change to a percent. You're correct. 125? 125 over there? Not done yet?
Yeah, I'm just about finished, but I was.
Well, let's see, I'm gonna do it and you can test it yourself on it, I guess. All right, so right underneath, we have what percent? This guy once again will be called X. Of big dot 76 equals 95. So you're gonna divide by 76. Let the calculator change it to a decimal for you. So I got 1.2, I got 1.25. And then all I gotta do is change it to a percent. So what am I gonna do with that decimal? Which way?
Oh, percent, you're gonna move it. Percent you go to.
I'm changing to a percent, correct?
Okay, so it becomes 0.
Wait a minute, let me tell you, it's not, you went the wrong way. If you started with 0, you went the wrong way. That way.
Oh, I started it.
So listen, percentages always look like a bigger number than the actual number itself. So 1.25 turns out to be 125%. You would put decimal to the right two places when you're going into a decimal. This should make sense. 95 is bigger than 76, so it's more than 100% of it, isn't it? Got it? All right, now we're gonna move on to some common applications, some of which you're likely to encounter in your life. The first one is buying something at the store and figuring out the taxes. That's something, I just want to make sure everybody knows. It's a surprise. Not everybody knows how shopping works. And I can't take anything for granted in that regard. So I must explain what happens when you go to shopping. Yeah, some kids, I mean, if we got people in high school still, they do come to the school. Their parents have bought their stuff their whole lives. They don't know how to shop. So let's see if we can, we're all on this, have an understanding here. Let's say I go to Best Buy and I buy a laptop. Okay? And it's on sale for whatever, it doesn't matter, it's on sale for, I don't know, $499.99. Now, when I go to pay for that, are they going to want exactly $499.99 from me? No. There's something called tax, which is going to increase your cost of buying. And it's always based on a percentage of the item you buy. And it's a fixed percentage, like up in Cleveland's like 8% or something ridiculously high number. Some people actually alter their where they shop to avoid high tax areas. It's all combined into one tax. There's a state, there's a county, and there might even be a city tax. All in there. They're all built in one thing. So they'll just say one tax rate. They won't. Although I mean, you could do each one and try to figure it sort of as all. So all you'll have to do is use 1%. Say, what's the tax rate that I'm paying here in Cuyahoga County? Let's say it's probably the same tax rate for the whole county, I think. So it might be 8%. So let's buy a laptop, 8% tax. See how much you actually buy it for. How much you actually pay, that is. So 8% is high, but I think you have cities like New York City and Los Angeles and Chicago and things where they're astronomical. They pay people higher to live in those cities. For higher cost of living. I was going to make an example of, okay. Let's say John. Buys a laptop. For $499.99. And the tax, let's call it sales tax. The rate is actually correct. The sales tax rate is 8%. I'd like to know how much you actually paid, or how much John actually paid for this when all is said and done. So how much did John pay for the laptop? Now, you always get some crazy decimals here, so just round to 2 places. For your final answer, just round it to 2 places. Would you? 2.0. Well, move to the left because you're going out of the percent. Remember, the number should look smaller when you go out of this. 100% should look bigger. So a good way is to figure out the tax first. Right? How do I figure out, how do you calculate? Tell me how you calculate the tax on this thing.
Multiply the total by 0.08.
Yeah, so multiply the price by the interest rate, by the sales tax rate. Okay, so the tax looks like this. Tax is 8% of 499.99. But we know how to do, what is that all supposed to be?
Multiply.
So I convert the 8% to 0.08 times 499.99. Tell me what you get when you do that multiplication.
39.9.
Would you say 39.99? I need, 1 second. Decimals won't work out if I do that. Let me see here.
It keeps going on.
Yeah, you just rounded 2 places though. I just want to see, what am I doing here? Times 0.08. 30, it's actually 40 if you round it to 2 places. I'll show you. This is what my calculator gives for this. These are the real. If I'm gonna round to 2 places, that means I'm gonna round to that decimal. Doesn't that one tell me to round up?
Yes.
So round up to 40. So I'm gonna put a little squiggle line for approximately. Because it does round to 40 to 2 decimal places. Now that you know how much you're paying in taxes, how do you figure out how much you're gonna have to pay when you get up to the counter?
You add,
Right, you add the $40 to the original price. So we can look at the total. Total. That's gonna be the price plus the tax. That's 499.99 plus 40. And this ends up coming on to be 539. Okay, so you figure out your tax rate. This is, I do stuff like this, but I don't do it exact. I estimate things as I'm shopping. So, you know, nowadays, I don't even remember the last time I carried any significant kind of money with me. So that's always done on a card anyways, but nonetheless, I gotta keep track because, you know, the limited amount in our checking account, we don't go over that. Yes, sir.
I got the same set of numbers.
Round 2 decimal places.
So I thought because spaces. I didn't, yeah, it was just because the spaces, I thought because in front of the period.
Mhm.
I thought
It will affect you move 2 places when you multiply by 2 decimals.
it's just because it was with 4 and I thought it's 5.
Any questions? I'm gonna give you one of these, just like it. I hope the first problem is similar to the one I just did.
you said move over 2, when we supposed to move over 4, that's what
For what?
you say.
I just said 2, no, you're never gonna do anything more than 2 decimal places when you're converting to and from a percent.
Oh, I did it backwards, I did it backwards.
Okay, I need a dollar sign on that thing. I didn't have one. Dollar sign. That was pretty good for a mouse dollar sign. Oh yeah, let's go in here and grab something. There we go. Antoine it is.
You must have run your own.
Two point zero.
Oh,
It's always two places, always. I think they have a percent converse, check this out. Yeah.
oh,
I think that's the decimal version of the percentage, that you just pick other versions of percent.
yeah.
It might toggle back and forth, I think, I'm not sure. Does that mean, do you guys already use the percentage button on your calculator? Do you actually really? I never use it. I always convert. I've not, I don't even, it never comes out when I try, I don't know if this even has a percent on it. The scientific calculators, let me see if it does. Oh, there it is down there. All right, so let's see what happens if I do that. It changes to a decimal. And that's it.
He wants to round up to $4.73.
Yeah, whatever, yeah, sure. Did you say $4? Is that what you said?
Well, no. What did you just?
Yeah, you're right, 473. So the tax was 473. So we go steps again. Better tax. So we've got $86 times 5.5%. As you convert this all, unless you like to use that. I don't trust, this is the one button on the calculator, I just don't trust. So I'm gonna put 86 times 0.055. And then you're right, it came out 473. And our total cost. That's where we're gonna have the price plus the tax. Our price is $86. You know, it's a math problem, made up math problem. When do you ever see anything for $86.00? Yeah. Whatever, $86 for this. Plus 4.73, and this comes out to be $90. 70 cents. Any questions? I'd like to get to the other styles of the problems. This one still, it's not that bad simply because this is something you do in life. You're familiar with this process. Some other ones will not be so, oh, did you see what happened? It logged me out. I don't know if it's still may have this though. Let's see that one, Maurice. Well, no, I guess I'll do the interest one first. So we'll talk about this here. What, just see how much. Oh. That you told. Yeah. Yep, yeah. This is just no different than the sales tax problem. You're doing the interest. So we have, so the interest. That equals 7% of $11,000. So change ourselves to a decimal for a little bit. And that ends up equaling $770. That thing, you can turn it sideways, you got your phone. It should be from the scientific calculator. When I first got a calculator, I was in elementary school, I maybe first or second grade. And I didn't trust it to give me correct answers. So I tested it. Every time I got an answer, I would do it by hand to make sure it was right. Nowadays, it's totally different. It's the opposite. You trust them without question. All right, so this doesn't seem like a big problem. There is another style of this problem that is more complicated. That's the next one after it. It complicates things, but not a whole lot. But it has a logic issue in it that we might want to talk about. So number 42 is the one I'm talking about. It's got a little bit of nastiness in it. Papers there.
was just to add both the interest.
Exactly right.
Amen.
How much was left over for the 6,000 for that one?
Say what now?
How much was left over for the other? You said 6,000 into 5.2, how much did you put in at 7%? How much is left over to put in 7%?
Just 312,
What do you think?
312? Talking about just the 6.
No, he goes, they have $9,000 to invest.
Oh, so we invested 3,000 together.
Right, 6,000 in one account, he had 2,000 left over to invest in the other account.
Okay.
So he has $3,000.
That is the word.
So then we have $3,000 at 7%. So you worry about adding these together because it's a total of these two things. On the one hand, we've got 6,000 times 0.052 plus 3,000 times 0.07. Your calculator can do this in one shot. I was able to type in the entire expression, and I got 522. You guys get that?
Yep.
522. Where'd you end up at? That should be 0.052. It doesn't go up.
Okay.
That's probably going to divide that number by 10.
I didn't read the question.
Now, remember, if you want to practice any of these problems, the odd ones have the answers right there. Okay. Where you have mouse, there you are. We have enough time. I'm gonna do these problems. They're so many. Yeah, maybe I could just grab in here some. Okay, 62 is an important style of problem, so let's go ahead and do this. It's similar, but not the same.
I'm gonna come run. You're probably going to maybe common mistakes. I like common mistakes. I've been doing this for a long time, so I know what's that. Right.
So how much?
Got anything going? Okay, I'll give you some hints. How much did he put into 4%? How much did he put into 4%?
Some.
Uh,
Oh, so it's two variables?
Oh, X. No, one variable used to describe two different things. Remember, we did this before.
Oh,
So I got X amount of dollars is going into the 4%. And then we have the rest. Can you tell me an expression for the rest of the money? That's not what I'm talking about. How much is left? So if they use X dollars for the one account, how much is left over for the other account?
So try.
So tell me what you get, tell me what you get.
Oh, I get it.
So here's what we have. So we're gonna look at our 4% will go like this. And then the rest, what, it's into 7%. So here's what we got set up. We've got an X here. I want to know how much goes there.
X plus Y.
No.
Times?
No. Looks like I have too much fun, I probably am, but
Right?
the issue is, this is where we did something before. Let me show you what we did. Is we did this before, I can't, or this, well, I'll write it down here. The idea here. I'm gonna make a line. And this line is 20,000 long, okay? Now, if I say some of it is X, can you give me a description using that letter for the rest of it?
20,000 minus X.
20,000 minus X. Check it out. If I take this plus this, doesn't it add up to 20,000? That's the trick that you need to know to do these problems. How to express the rest using the one letter that you're gonna use. So let me extend this down to here, so I can put for that, the rest is 20,000 minus X. So in the one account, he has X dollars. So in the 4% account, he has X dollars. X dollars at 4%. And 20,000 minus X at 7%. They actually tell you what that ends up equaling, don't they?
Yeah.
What does it end up all equaling total?
1,130.
1130. Now let me convert everything. This first part is 0.04 times X plus 0.07 times 20,000 minus X. And all that equals 1130. Now, it's nothing, no different than any other type of problem that you solve. Can you tell me what you would do first to solve this?
I would divide 0.4.
Why would you do that? That's not what we say to solve an equation. What we want to do is try to get X all alone, don't we? And then I'll subtract, add whatever to make that happen. What's the first thing I need to do in order to start working this problem at all?
you're gonna add. both.
No. Anybody know? What's the very first thing I must do?
Multiply the inside of the parentheses by 0.07.
Right, you are going to distribute
Oh,
the 0.07 through these parentheses so that they're gone. That's gonna help you get the X by itself. All right, so I have 0. 0 for X. Plus, when you multiply it through, I think, is that 140? 140, is that 140 anybody?
Yeah. Well, yeah, number 0.
Is there another 0 out
Yeah.
there? Yeah, another 0 was there. All right. Now then, I'm gonna combine my X's. So if I combine 0.4 with negative 0.7, I'll end up with negative 0.03X. So I combine my X's. Are you with me? Follow that? Okay. Now what am I gonna do next?
Subtract 1400.
Subtract 1,400 from both sides. Okay, we're getting ready to finish off. What now?
Divide each side by negative 0.03.
Negative 0.03, exactly. That's good because the two negatives on the right cancel and it becomes a reasonable quantity this time. Did you get 9,000 with these?
Yeah.
Oh, good. Oh, I don't wanna, I hate doing these things, I just kind of like a machine. It's kind of most fine. Did you guys, did you get 9,000 for this? How much was available in the other account?
11 or 11,000.
11,000, do you understand, 11,000 was available in the other account? So that means the 20,000 minus X was the other amount. Right, that's the 11,000 we have there. So they did 9,000 at 4%. And 11,000 at 7%. Side glance, but they'll have 2 boxes for you to fill in on homework. There's something about percents. I'm not exactly sure why, but they do cause people a lot of stress. The reason the percentages are invented is so that you can compare to two different quantities that may look absolutely different. Like if I have a fraction versus another fraction, I may not know which one's bigger until I go to decimals. Once you go to decimals, it's easy to tell which one's bigger. All right, let's pop in here. Looks like this will be about the last problem of the night. I don't want that one. No, I don't want to do that. All right, they're the type here, they're keeping me from it. Got to 56. So I'm going to step through this one because it's unlikely. I'm not assuming that you've ever seen anything like this style of problem ever. So we're going to go and do it. And I'm going to step through and show you what the tricks of this one. It's a very specific type of a problem.
And before I do that, let me just ask a couple of questions.
When you, let's say you purchase anything, you know, any soda pop, if you look on your bottle of pop, it has percentages, doesn't it? If you buy beer, doesn't it have a percentage alcohol? And the higher the percentage, the drunker you'll get, correct? More alcohol content, the stronger it is. So when you're looking at, how do you determine, like say I got a beer, how do I determine how much alcohol, physically alcohol is in that beer? How do I do it?
And the second percent.
How do you determine? Well, it says, but let's say it says, 5%. We're gonna make the numbers work out well. So I got, it says 5% alcohol by volume. A 12-ounce bottle. How much pure alcohol is in that bottle? 5% of 12. So I'm gonna move this and I'm gonna do this little sample quick, and then we'll do this problem because it will, that works.
6 fluid ounces?
12 fluid ounces.
Yeah, but wouldn't just the alcohol volume?
Oh, yeah.
So let's go ahead and do it. So a 12 fluid ounce. And beer has an alcohol content. You could say it this way, 5%. You know, say alcohol by volume, I'm not gonna bother with that part. So what you do, the amount. So the amount of pure alcohol is 5% of 12 ounces. And I think that's gonna be, so you're gonna actually do 0.05 times 12. And did you say it came out to 0.6?
Yeah.
0.6. That's 0.6 fluid ounces. That's how much alcohol is in there. That's what we're gonna be keying on, is how much pure substance is involved. I'll show you how we can right here, this one here. I have a picture too that helps with these problems if you would like. The use of a picture, but you don't have to have one. So, how many milliliters?
40?
You already did it.
Oh, no, I was thinking.
Wait, it says how many milliliters, you know what it's doing? What is it telling me this is supposed to be?
X.
Of a 17% alcohol solution must be added to 40 milliliters of a 30% alcohol solution to get a 12% alcohol solution. So let's take a look. We have X at 17%. Plus, they tell you the other amount, don't they? That one was at 3%. And it was supposed to equal, what, 12%? The only problem is, I don't know the quantity. How much do I have at 12%?
Isn't that what we're trying to find out?
No. We're only trying to figure out the value of X, actually. That's all it asks you. How much total liquid is in there? All right, we know we got 40 milliliters, right? And you got X milliliters. So how much is that together? X plus 40, not 40X, that's times, X plus 40. So you need to put that over here. That's the total amount that you have. And then you're gonna convert all of this to mathematics. So that's the equation that I'm going to have. So this X plus 40 is representing the total amount of liquid. You tell me what it is you do first before you go to solve this. The word I'm thinking of. Simplify? Well, yeah, simplify, but what does that mean to do? I want the word for it.
Start with a D.
It does. It rhymes with distributive.
Distribute,
Yeah.
distribute property.
Yes, distributed property. Very good. So you would pop this through, right? Here and here. I think we're gonna get 0.12x plus 4.8. Check that number. Here, I think we get 1.2. Tell me if all my numbers are correct. Well, I mean, can you finish it from here? Do you need me to finish this? We can talk about the answer the next time, but class is over technically right now. So I'll stay and solve it if you want me to, or I can let you have it. And you can talk about it next time. Do you guys want to stay over for next time? With that,
I'm gonna shoot.
you want to go for it now?
I'm just, yeah, I'm gonna try.
All right, we're out. I am so hungry. Pizza's waiting at home. So we're gonna do, all right, well, what would you do next then? I don't know what you do next.
We worked, 0.768.
What are you gonna do with it? Tell me what you're gonna do then.
Well, I'd like to take my stuff to the left.
Fine, take it to the left side. So tell me, okay, mathematically, what are you doing?
Okay, I will put the 0 point.
It's not put, use a mathematical term. Be precise. What are you doing to move it to the other side?
Add,
No, you're not. You're doing the opposite of adding.
divide. I was subtracting, sorry.
You're subtracting it from both sides, right?
So that becomes a minus.
Negative 0.12, because you like your x's on the left, you said.
Yeah.
I'll make sure that I put it underneath my like term over here. Plus, here we're gonna have 0.05x plus 1.2 equals 4.8. Now what are we gonna do next? What are you gonna subtract? The 1.2 from both sides, very good. So subtract 1.2. My point is, even though I'm hungry, I won't sacrifice my students. All right, so that goes away, we're gonna have 0.05x is going to equal 3.6. Right, and so x then divide by 0.05. That has the effect of multiplying this by 20. So this will be 72. That's all of that. All it was asking was for how much, so and we found it. So these are what they call mixture problems. You'll encounter a few of them on the homework. And they all work pretty much like this. The only thing that would be different in the homework, let me just point you into it, is, you know how we had 40 milliliters? They might not tell you that amount, and then you're gonna have to do X and like something minus X. You know what I'm saying? That could happen, so you need to practice that. But that's all I got for you then.
Thank you for the class.
Sure, no problem. Let me stop this. And stop the recording.